I feel like we could go over a little bit better. I'll take the blame. I want to talk about, so this is where we're going to be taking notes here in a second, but let me just go over something from yesterday real quick, okay? Just to make sure we're clear on it, because I had a lot of questions. And it comes from this right here, number 17 and 18. I feel like there was a little bit of confusion, my fault maybe, confusion about the difference in these two questions. So I want to make it clear to you, so if you just give me 1 second. The first day that we started this stuff, Friday, we talked about a really basic concept of increasing and decreasing, okay? And that is literally just looking at a graph. Where is it going down? Where is it going up? So decreasing, increasing, decreasing, increasing, right? So roller coaster, down, up, down, up. Something else I want you to make a connection on. When we're decreasing, the slope would be negative. When you're increasing, the slope is positive. Negative, positive. So decreasing, negative slope. Increasing, positive slope. Okay? Constant would be a horizontal slope or slope of 0. Okay? So that's when the function is decreasing or increasing. They mean the graph. Look at the picture. Is it going down or going up? Okay? Then we talked about, Gary, pick your head up, please. Then we talked about concavity. Yesterday was the new concept, and I think I confused some of you about that, so I want to just talk about that. Concave up and concave down. And we talked about the word slope is the same as rate of change. They mean the same thing. And I think the increasing and decreasing was confusing because on Friday we talked about the graph increasing or decreasing, okay? Slope increasing or decreasing doesn't mean positive or negative, okay? What it means is literally the numbers getting bigger. So when you have a concave up portion of your graph, you have negative slopes and positive slopes. You have both. So that's not what that means. It means they're getting bigger. And I just gave some examples here. Like you could have this is positive 1/2, positive 2, positive 3. The numbers are getting bigger. Happens over here too. Even in negativeville, we're getting bigger. Might be like negative 2, negative 1/2, negative 1, whatever. But all the slopes from left to right are increasing, getting larger. That's for concave up. And concave down, they're decreasing the whole way. They're going to be going from left to right. All the slopes are decreasing. It has nothing to do with positive or negative. It's like the value of those numbers. So decreasing, you could have like negative 1/2, negative 2, negative 3. That's what it means, okay? So going back to those two questions that were kind of confusing. So the first question, is G increasing or decreasing? That means the function, up and down, roller coaster, at x equals 1, okay? So this was also a little confusing, the points they used on here. We had this point right here identified for us, right here. It's 1.2 is the x value of this point. What they're asking about in this question is x equals 1, which is a little bit to the left, okay? So it's on this portion of the graph. X is 1 is like right here approximately. It's to the left of this 1.2. So is the graph decreasing or increasing at x equals 1? It's decreasing, right? It's going down. And how could you further explain that? Because the slope is negative. If we are decreasing, the slope is negative. If the slope is negative, we're decreasing. They go hand in hand. So that's what that first one was talking about, first question, okay? The second question considered the rate of change at 1. What is the rate of change at 1? And so if you look, x equals 1 is on a concave down portion of the graph. That means the rate of change is decreasing. It has nothing to do with it being a negative or a positive slope. Concavity has both positive and negative slopes on it, okay? It has to do with the actual value decreasing, like I showed you on the last picture, okay? So the confusing part, I think, comes in with decreasing and increasing being used as terms but meaning two different things, okay? Does that help anybody? Do we get that kind of? Yeah? Okay. All right, so let's go to today's notes. It's pretty short. There's pretty much one type of problem we're doing. And it's kind of cool. So let me read to you for a minute. We have seen that the slope of a line can be interpreted as its rate of change. So right off the bat, guys, let's not forget, these slope and rate of change, interchangeable. We're going to say those meaning the same thing. I might call it slope, I might call it rate of change. And that the formula, the function, is defined as the rate at which the output quantity changes, that's your y, with respect to the input quantity, which is your x. If the graph of a function is not a straight line, we use the terminology of average rate of change. In other words, AROC. Okay? Average rate of change. So what we're talking about here is this. If I was talking about a line, a straight line, and I pick any 2 points on it, and everybody picks their own 2 points. Let's pretend we have a graph on coordinate plane, and we all pick any 2 points we want, and we plug it into the slope formula. What are we all going to get? Come on, what are we going to get? Everybody's going to get the same answer. The slope of a line is constant. Any 2 points, the distance between any 2 points is constant. If the slope of this line is 1/2, you could get that slope no matter what. Up 1, right 2, up 1, right 2, up 1, right 2, forever, right? Forever, never, never. So on a line, the slope is constant. It's constantly changing exactly the same. But what about on a curve, okay? So that's what this is all about. And it's like the key to calculus is what we're kind of touching on without you even realizing it. If you look ahead to the homework, you're going to be finding the slope of a line that connects 2 points on a curve. So given 2 points, what is the average rate of change between those 2 points? Why don't we call it slope? Because slope infers it's going to be the same between any 2 points, and it's not. We could pick 2 different points. Everybody in this class could pick 2 different points on a curve, and we'd all get different answers, okay? On a line, we'd all get the same. So there's going to be specific intervals, x values, that we're going to have to find the slope of. So let's just look at that formula again. I think this will make complete sense to you. AROC, change in y over the change in x, sometimes called slope. And there's that formula I think we all have memorized. If you don't, it's important that you know that formula. One thing I would ask is, does the order matter in that formula? Can I plug in any which way I want? Well, it's kind of like in some parts, right? The one thing that is very certain is y is on top, x is on bottom, okay? But if you want to switch the order of the y's or switch the order of the x's, you can, as long as you keep them in the same order within each other. Here's what I mean. So in this first example, it says to find the AROC of this graph, whatever. We know it's not a line, it's a cubic, some curvy graph. It's got curves in it. We don't even need to see it to do this. Over the interval of 1, 3. Guys, that's not an ordered pair. That's not the point 1, 3. These are your x values. On the x-axis, I want to chop out that piece of the graph from x is 1 to x is 3, wherever it is, and I want to know the average rate of change between those two x values. So you could kind of think of these as x sub 1 and x sub 2 if you wanted to, or the other way around. But just know that they're x's. That's what those are, not an ordered pair. So I don't have the whole formula. I don't have all the numbers I need. I only have the x's. I need the y's, right? So in a minute, I'm going to plug 1 into this and 3 into this and get the y values. So let's look at some of the notation so you understand the language. So AROC will equal, and I'm going to put the 3 first. I usually try to put the bigger number first. It's not a rule. You can put either one of these first, but as long as the denominator matches that order. So you could have done f of 1 minus f of 3 over 1 minus 3. They just are always going to match. So pick the way you want to do the numerator, make the denominator match. And remember, the notation is so important. F of 3, that means what do I get when I plug a 3 in for here? That's really your y value when x is 3. That's what that notation means. Okay, so I need those values. I don't have them. So just find some workspace somewhere and plug 3 in. Right? 3 to the 3rd power. And sometimes I do the work ahead of time. Like, we don't all need to pull out a calculator. I mean, you can, but it's not like I want you to wait to do it. I know you guys know what I mean when I say 3 to the 3rd power. I got 27 minus 12 and then 15. Okay? So I know f of 3 is 15. Let's do f of 1. So plug a 1 in. And then I can write 3 minus 1, or I can just go ahead and make it a 2, right? Whatever. Just simplify this. I get 18 over 2, which is 9. The average rate of change between these 2 points on this crazy curvy graph would be 9 over 1. To get from one point to the other, I'd go up 9 to the right 1. That's just between these two x values, just between these two ordered pairs. Okay? Yes? Well, the formula is, it was 15 minus, right? I had 15 minus negative 3, but two negatives cancel out to become a positive. I just made them both pluses. Okay. So your calculator would have done it for you too. 15 minus negative 3, it would have given you 18. Good? Okay, let's interpret a word problem. Let me just sum up what that whole sentence says. They're giving us this XY chart, we call it, this data, where we have time. And if you remember, time is 99.9% going to be your X values. So if you're labeling a graph, time is usually the X-axis. And then this is the total amount of garbage in millions of tons produced at, I don't know, University of Michigan Center for blah, blah, blah. Okay? So this is garbage produced. We can call this Y, right? Or we could call it F of X. They're the same thing. Or G of X for garbage, whatever. Now, what they are asking for is the average rate of change, the AROC, in trash between 1985 and 1990. So that's just these 2 years. So this is exactly the same thing we just did, except we don't have to plug our X values into an equation to get our Y values. We just have to know how to read the chart, right? So pick which year you're putting first. It doesn't matter. If I do 1990 first, it would look like that. 1985, and then I would match that order in the denominator. I usually try to put the bigger number first, just to avoid negatives if possible, but it's not like we should be afraid of negative numbers. It's just a habit of mine. So it really doesn't matter what order you put them in. Okay? So in the last problem, we had to plug this X value into an equation and simplify, right? The F of 3 and the F of 1. But here we can look at the chart. In 1990, the amount of garbage was 208.3 million tons. And in 1985, it was 166.3 million tons. If I subtract those two, I get 5. And then putting this in my calculator, 208.3 minus 166.3 divided by 5, I will get 8.4, but let's write it correctly, million tons. How did I know that? It says it right here. So that was the average rate of change between in those 5 years of increase. It's a positive number. The garbage went up, okay, which we can see right here. Okay, so just using that formula, just using the data a little bit differently. And then part B, did the rate of trash ever decline in these years? Okay, so let's start with that, and then we can answer the rest. So as I look, I just scan left, right. So we're going up, up. Every number is getting bigger, 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 up until these 2 years. In 2005 to 2010, we had the only decrease in garbage. Every other year it went up. So yes. When did it happen? So we just answered, and I'm trying to help you here, like for an FRQ, you answer all the parts. Did the rate of trash decline? Yes. When? In the period from 2005 to 2010. Right? Now they want to know what was the average rate of change during this period. Okay, it's just what we just did, just two different numbers. We're using these two this time. So pick which one you want to put first. I'll change it up. I'll put the smaller year first. But it's not wrong. You don't need to erase it if you didn't do it like that. It doesn't matter. I will look at the chart, and I will pull out the amount of trash for 2005, amount of trash for 2010 over the 5-year period. Calculator work. put it in my calculator for us, and I got negative 0.52. How can we interpret that number? What does that mean? What would I write in a word problem when it says, what was the average rate during this period? Do I write negative 0.52? No. What do I write? Anybody know? What does that mean? Excellent, Sadie. Thank you, Sadie. Yeah, it declined, decreased. That's what a negative slope would mean, right? Increase would be positive numbers, decrease would be negative numbers. Think about that slope thing we just talked about. When the graph is increasing, it's a positive slope. Decreasing is a negative slope. So it decreased by, not negative 0.52, that's like a double negative, decreased by negative. We decreased by 0.52 million tons. So notice how I did not put the negative in there. If this wasn't a word problem, it was just asking for the AROC, you just write negative 0.52. But we're translating that number into applying it to the word problem. Okay? Sorry. Yes, thank you. Negative 5. This answer is still negative, though. Sorry. Yeah. 2005 minus 2010 would have given me negative there. Sorry about that. Thank you. Anything else? A couple more. No? All right. Example 3, quick and easy. Kind of confused me the first time I looked at it, so I'll point some things out to you. Let me read. After surgery, you're given a pain reliever. The level of the medication will decrease slowly over time. Makes sense? Let C of T represent the medicine's concentration in your body, and write an expression, that's the key word, write an expression for the rate of change of the medicine's concentration level over the period from T is 15 minutes to T is 90 minutes. So C of T, that's like our Y value, right? And T is our X value. So what they're saying is, what happens to the concentration? Again, the order could be different. That's how we've been setting these up, right? Concentration of the pain reliever after 90 minutes and 15 minutes subtracted by the actual time. But they didn't give us a chart, an equation to plug it into, or anything. So they literally just want the expression. This is really just testing our ability to write it, to set it up correctly. And again, the 15 and the 90 could be switched. There's only one thing we could do to simplify this, and that is the denominator. 90 minus 15. 75. And that's it. It's set up, and if they wanted to extend the problem and give us a chart of information, we could then plug those numbers in up top, but we don't have them. So this is just writing the expression, setting up the little equation. Okay. And last one, and we're going to just do A, B, and a little bit of C. This is kind of connecting to what you guys did as your last two homework problems yesterday, where you had to actually draw the graph to match what the car was doing or whatever. So what we're going to do is explore the distance a car travels over a 2-hour period shown at the right. So we have our x-axis, we have our y-axis. Time, as usual, is our x, and distance is our y, or f of x, or d of x, whatever you'd want to call it, okay? They didn't specify, like in the last problem, they said c of t, so we used that. They didn't give us something, so you could use z of x if you wanted. It doesn't matter, okay? But just know that that's y, okay? And it starts at 0 minutes to 120 minutes, which is 2 hours. Distance of 0 miles traveled up to 100 miles, okay? So what is the AROC, average rate of change, the car travels? Well, when? It doesn't say from this time to this time. So when it doesn't specify, it means it's inferring the whole time, okay, for the whole trip. So we want y's on top. So f of 120, that's the most amount of time we went, furthest distance, right, from 0 to 120. Again, the order can change. So using the chart, at 120 minutes, our y value or distance was 100. At 0 minutes, we went 0 distance, right? We hadn't started the trip yet, over 120. So 100 minus 0 is 100. 100 minus 0 is 100, divided by 120. That's how we put a fraction in. Divide it. And then you hit enter. Remember, you always get a decimal. So we hit math, enter, enter. Okay? So we get an answer of 5/6. That doesn't really make a lot of sense. How does that tell you how fast the car was going over this amount of time? It doesn't. So there's a little conversion formula we need to use. I never have enough room. Let's put it over here. It's very simple. You take whatever you got as your answer and you multiply it by 60 minutes over 1 hour. And it'll convert it to miles per hour. So since the denominator is a 1, you're really just multiplying your fraction by 60. So I have, let me start over. If I put it in my calculator, it'd be 5 divided by 6. And if you hit enter, it's fine, or you can just wait, times 60 over 1, which is 60, and we get 50. That means 50 miles per hour. So we're changing it to miles per hour. Now listen, if this had been a straight line, it would have been the same speed the entire time, which really doesn't make sense. Who can maintain the same speed for 120 minutes? So you can see the speed and distance changes as you go, okay? So look at this next question. How fast is the car going from t equals 30 to t equals 60? So they want to know a specific piece of the trip. So it's a specific part. So again, any order, we're going to have f of 60 minus f of 30, or the other way around, as long as we match up. Okay. At 60 minutes, we're going 40 miles per hour. At 30 minutes, we're going 20 miles an hour. 60 minus 30 is 30. So 20 over 30, or 2/3, get to that point. Multiply it by a conversion formula. And I'm being a proper math teacher here and writing all this out. You're really just typing in times 60 in your calculator. So 2 divided by 3 times 60 over 1, which is 60, gives me 40 miles per hour. So it makes sense that it's going to be different. The speeds at different portions of the trip are going to be different. We zeroed in on this portion of the trip where this was like over the whole trip was the average, okay? But it changes throughout, okay? Last thing, when is the car traveling the fastest? And we could do how fast by doing another formula once we find that interval. But what we're looking for is just, what I'm looking for is, can you guys look at these little segments and tell me which segment means we're going the fastest? So from what to what? It would either be from here to here or here to here. It's got to be like 2 endpoints. Where do we think that we're traveling the fastest? 70 to 90. What about the graph tells us that? It is steeper, right? It goes up quicker, okay? So from 70 minutes to 90 minutes. It's the steepest part of the graph. It has the steepest slope, going fast, quicker, okay? But I think we understand the formula, so I'm not going to make us find it, all right? So this is it for the notes. I'm going to get you started on the homework, do a couple with you. Please write the assignment down. Yep, go find the page. Practice set 1 always goes with day 1. Now, when I don't write odd or even, that means all. So 1 through 4, all. 5 through 11, odd. So go ahead and make sure you write that down. If you want to circle the problems, I'm going to do the first one with you. Give you a chance to get situated, though. Say it one more time. I always post them. Yep. Every answer plus the key to the notes if you're absent and a video. So I'm just going to write on a piece of paper because I don't have a blank one of these in front of me. So I'm going to do number 1 with you. I'll do 1 and 2 with you, in fact. All right. So they're giving you, find the average rate of change, so find the AROC for each of the following graphs over the given interval. Remember what an interval is. It's a piece of the x-axis. So this is not an ordered pair. This is 2 x's, right? It's just 2 x's. And so I need the y values. This is almost basic Algebra 1 math, just with an extension a little bit. So if I want these 2 ordered pairs, I could just use the graph. I'm not plugging into an equation like I did in the first example, the x to the 3rd power. I'm not pulling it out of a table of values. I can just look at the graph and find the y values. And then I can just use my AROC/slope formula. So at -2, I'm at 4. At 0, 1. So those are the 2 ordered pairs that we want to find the average rate of change or slope between just those 2 points. Now, looking at the picture, you already know we should get a negative number, because that's a negative slope between those 2 points. And this is just using, put your y's on top and your x's on bottom. And you get a negative slope, which makes sense. Okay, those specific points have a slope or AROC of that. Any other 2 points, you're going to get something different. It's not a line. That's why we call it an average rate of change. So this one is 2 and 6. Again, get it in your brain that those are x's. So what you need are the y values. And if I look at the graph, at x equals 2, y is -1, right? At x equals 6, y is -5. So I'm just pulling the points off the graph and then slope. Get this? The work is here too. So 2 more of those and then some like you did. And I'll fit 9 and 11 up there in a second, so I can move it up. A little bit more. having all these problems, you're given the two x values. How do you find the y values? Do you look at a chart? Do you look at a graph? Do you have to plug it in to find it? That's the differences.